So welcome back to the day 2 of daily programming challenge. So let's start with this question. Let's denote the f of x function for the string x as the number of distinct characters in the string contains. For example, f of abc equals to 3, f of bbbb equals to 1, and f of babacab equals to 3. Okay. Given a string S, split into two non-empty strings and B such that fa plus fb is the maximum possible. In other words, find the maximum possible of f of a plus f of b such that a plus b equals to s. The concatenation of string a and b equal to s. Okay. And f of a plus f of b should be maximum as possible. Number of test cases, length of string. Okay, this n is given as 2 into 10 power 5. So we have to work in the big of n time complexity. Then the questions. Then okay, well, what do we have here is we can a two times two. Okay, abc, hmm, 7 abc. Okay, then here we'll be having a 2. How can this be splitted? Abc. I think as soon as just when the like when any character repeats again, we can terminate the string from that, from the left side of that character. As we can see here, a is being repeated, so we can just terminate a from here, and then remaining distinct values we can calculate for the string. And I think that's the thing which we have to do, because 1 2 3 4 5 6 and then 7 8 9 and 10. Yeah, I think that's the only thing which we have to do. Let's just try. So my logic is, suppose this is a b c d. So a got repeated again. I'll just split it here, then function for this, function for this. So well, let's move the coding part. By the way, these problems are rated around 1000 on Codeforces, so they're not too that much hard to solve. Mm. What we can do is create a set of characters. Or else, can we do it by vector? Let's just try. Suppose if I want to do the v dot find function, I think we don't have the v dot find thing here. Asset is good because it will just do it in the log n complexity. First, let's just check what does this function do. I think we'll get the index. Yeah. insert it. Why am I getting this error? Hmm. Okay, wait. Hmm. First of all, let's check with this C1. What I'm doing is I'm creating a integer C1 which will store the size till where we find the character again. Okay, well, what we can see here is ABC 3 A1 6 1 2 3 4 5 6 1 2 3 4 5 6. Okay, well, now when we are done with this, 1 0 1 2 3 4 5 6, we'll create another set of character so that we can store the frequency of remaining elements on the right side. Character s2 I comma n for int I equals to c1 minus 1 equal to 1 I less than n I plus plus s2 dot insert stry, then c2 is equal to s2 dot size. We'll just print c1 plus c2. 2 7 2 11 4. Okay, I think some error we got. 1 2 3 4 5 6 0 1 2 3 4 5. Let me just keep it as c1 then. Okay, well, so yeah, that's it for this question. It was quite easy. You have to just see where the string will start, where the character start, any of the character, if it starts repeating again, there itself we can divide the string so that we'll get maximum value of f of a and f of b. It's quite intuitive. Once you try it, you might get it. Hmm, wrong answer on this too. Let's check. 26 number differ. What is the 26 number here? 26 numbers just differ. Expected 8 found 9. So it's the 26th test case. 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 26. Okay, this is the test case. We'll try it. 1, 9, 1. Expected 8 found 9. CEXECMDK 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 can be the maximum length. Or maybe I have made some mistake in reading the question. Split into two non-empty strings, maximum as possible. The concatenation is equal to as 1, 2, 3, 4, 5, 6, 7, 8. 9 can also be the maximum, I guess. Because 9 is only the maximum thing which can happen. Because if there is any string, suppose I have 8 characters 1, 2, 3, 4, 1, 2, 3, 4. What I can do is I can create a max up to 8 distinct elements A, B, C, D, then A, B, C, D again. Suppose I have 9 characters, then again it's quite possible for me to do, because if I create 9 places 1, 2, 3, 4, 5, 6, 7, 8, 9. Now then again I start saying A, B, C, D, E, and again A, B, C, D. I'll be having 4 characters here and I'll be having 5 distinct characters here. So it's possible to attain a length of 9, but why is he throwing an error for this thing? Let's just check the editorial. Question D. Let's check all splitting points. We denote a splitting point at the last index as we take a remainder. We need to keep dynamic count of number of distinct characters in both string first and B. Using two frequencies arrays and adding one to B. What about? I didn't get it. Let's check all splitting points. We denote a splitting point as the last index of the first string we take, and all the remaining characters we need to keep a dynamic count of number of distinct characters in both string. And so we do this two frequencies and adding one to distinct count of either A or B. The frequency of character is greater than 0. We denote the splitting point as the last index of the first string we take, and all the remaining characters will go to the second string. Okay, we need to keep a dynamic count of the number of distinct characters in both strings A and the second string. We can do this using two frequency arrays and adding 1 to the distinct count of either string A or B when the frequency of character is greater than 0. Two frequencies arrays adding 1 to the distinct count of either string A or B when the frequency of a character is greater than 0. The explanation is not quite clear. The last line I didn't get it. We can do this using two frequency arrays. Frequency 2 and adding 1 to the distinct count of either string A or B when frequency of a character is greater than 0. I think we can try it, but n goes till 2 into 10 power 5. So I think we require n square time complexity. Suppose if I split this thing from here, A, then I have to check for again this string A and this string B. What is the problem with 9 here? Because it just obeys all the conditions in the given test case. CEXE, CM, DKM. So I can split as CEXE and then CM, DKM. CXE will be 1, 2. Oh, wait. Or else I'll split it as CEX, ECM, DKM. What will happen then is CEX will need like 3 characters here. Then ECM, DKM 1, 2, 3. Okay, I think there is an error in my code. Yeah. So what do we have? What the mistake? What did I do here is well, C1 equals to let's just apply the break here and get out of the for loop, then try doing it. Okay, that also works. Fine. Again, wrong answer on test 2. I think 1/60th numbers differ. Expected 9, found 8. Hmm, FA plus FB. Or else, what can I do is I'll make a frequency array which stores the frequencies. 1 minute. Yeah. What I can do is I'll create the frequency arrays which will store the amount of distinct elements till that particular index. This is A, this is A. No, wait, that will not work most probably because when I split the array, the amount of distinct elements will change. It won't be of any use. Try A, B, C, A, B, C, D, A. Split here. What if I remove this condition and try again? Wrong answer on test 2. I think the same test case. 160th number differ. No. How do I know which one is the 160th test case? What if we try his approach? Characters in A. We keep a dynamic count of number of distinct characters in both strings and B. Two frequencies arrays and adding 1 to the distinct counter whether when the frequency of a character is greater than 0. Two frequencies arrays. Okay, then. Count of this thing and then minimum of 1 comma count of I comma minimum of 1 comma p of I. Well, that can also be done. Mm. So what did he do was he stored all the frequencies of all the elements in the array. Then he just applied the for loop again in that, the for I equal to, like he applied the for loop for the array of 26 elements. So that didn't consume much time complexity because anyhow the sum don't exceed 2 into 10 power 10 power 5. So yeah, and time limit per test is 2 seconds. So we could just go for that approach as well. String is int of f1 of I think I could have, like, if I thought for some more time on this question, then maybe I could have got a better idea. So what I'll do is answer equals to maximum of answer comma f1 of si minus a plus f2 of si minus a, and we have to take the distinct elements. So I'll be taking the minimum of 1 comma this thing. What's wrong with this thing? Minimum of 1 comma and of o equals to 1. Okay. Yeah. So that's it. I think that was the thing. What we did was we created a frequency, two frequency arrays for the splitted array on the left side and for the splitted array on right side. Then first we stored all the frequencies into the array, first frequency array. And what he did was, when after iterating till some elements, when we iterated over any element, we deleted the frequency of that element, and then in the first array and incremented in the second array. This didn't work. I think I made a mistake somewhere. Minimum of, okay, okay. A B C A B C D. So this is the F1 array and this is F2 array. Suppose I take a string A B C A B C D. So in the F1 array, we'll have frequency of the respective elements A, B, C, and D. Frequency of A is 2, frequency of B is 2, and frequency of C is 2, and D is 1. Now we'll have F2 array. And I'll just simply store the frequencies as I go on iterating through the elements. Suppose I iterate through the first element, then frequency of A will be incremented by 1, and similarly here it will be decremented by 1. Now then what I'll do is I'll just iterate through both the frequency arrays, then I'll find the score, which will be minimum of, like that's something, but I am finding the distinct elements, amount of distinct elements. One plus, okay, I guess I got it. What I didn't do was I didn't increment it after each thing. This might work now. F1, F2, F1 of Si minus A minus minus, it will be 1, and F2 of Si minus A plus plus, this will become 1, and score equals to 0, and then O equals to 1, score will be plus incrementing of F1 1 plus 1, then this will be 0, and this will be plus 1 plus 1 plus 1. The answer will be 5 for this case. 1, 2, 3, 4, and 5. And if I go on doing, suppose if I get a 1 over here again after the B thing, then this will become, and this will become 1, then it will be 4 plus 2, 6, and then after C it will become 1, and what we'll get is 4 plus 3, which is 7. But why am I getting weird answers over here? Anyways, I'm reinitializing the score. F1 minus minus and then F2 plus. This might work. I did the mistake that, okay, I was calculating for Si minus A, so it was going on repeating. So this will work probably because I'm doing it for all the characters present inside the string. So that this will be the final code. But I didn't get why my earlier code didn't work, which failed on 168 test case. Even equals to dot size, then break. What if I try putting this for loop inside this, and maybe because the string is the character is appended again here, but this is a value which stores the static variables. Okay, this code will work definitely because it was a copied one. How do I submit it? Submit code. What I'll do is I'll make some changes to this and try submitting it again, the previous code. It will fail anyways. Got compilation error. C1 was not declared in the scope. C1 does not name a type. Oh, sorry, it was constant integer. Maybe this will work. Again, I got error. Read only variable. Well, I think this was the only solution. Or else, let's check what other people did. We can check other submissions as well. What containers did you use here? Unordered map and unordered set. Okay. If container dot insert count plus plus. Long, then map, unordered set, and then the unordered map equal to 0 if container dot find of string s equals to container dot end, then container count plus plus. Okay, fi equals to count. Till every index he found the distinct element. Similarly, he did for the reverse. In the reverse case, he found distinct elements till every index. This thing means that if the element present in the string is not, I mean, is a distinct element, like it's first time being printed in the, I mean, inserted in the container set. So it's basically the distinct element. We are getting the count of distinct element up to that particular index. Now what he did was prf first equals to PR dot second is iterating uh, F map and complement. Okay, well, he applied the idea which I got earlier. Like he just maintained the count of distinct elements till every element. I mean the count of distinct numbers till every element. What he did was till this index on the both left and right hand side he found the count of distinct elements. So till this index we'll have F as 1 and then B as this thing count of distinct elements till here. Similarly till this index we'll have it as 2 and B as count of distinct elements till this thing. So I just added and checked which one will give him a maximum sum. Container dot find, container dot insert count. Yeah, we'll move to the next question. Minimum LCM. You're given an integer n. You're asked to find two positive greater than 0 index integers a and b such that a plus b equals to n, and the least common multiple LCM of a and b, the minimum among of possible values of a and b. If there are multiple answers, you can print any of them. Number of test cases a and b, answer problem, you can print any of them. You're given n. Find two positive integers such that a plus b equals to n, and the least common multiple of a and b is the minimum among all possible values of a and b. So n is given till 10 power 9. We cannot go for big of n or big of n square time complexity. LCM of a and b is minimum among all possible values of a and b. If there are multiple answers, you can print any of them. There are 8 possible pairs in the second example, but he found out with the minimum LCM. How can we do that? N equals to 2, then 1 comma 1, and if n equals to 9, 9 minus 1 comma 1, 9 minus 2 comma 2. So it is basically 9 minus x comma x, which will give us the minimum LCM. It's not GCD anyways, it's LCM. LCM of 6 and 3 is 6. LCM is least common multiple. So we have to iterate till n here if we want to find the minimum LCM. But without iterating, how can we find? That's the thing. Third example, 5, 1 comma 4. We go on checking for pairs 5 minus x, comma x. Among them, the pair with minimum LCM is 1 comma 4. X equals to 1. What is LCM of 2 comma 3? It will be 6. So if we observe carefully, LCM repeat till n by 2. Like till n by 2 will be getting same LCM, then after that they start repeating in the reverse manner. 4, 6, 6, 4. That's what he's trying to hint towards us. 9 by 2 is 4. And the problem is we cannot go for n by 2 as well. It will be in the order of 10 power 8. And this is 100. We have a time limit of 2 seconds. Maybe it's any solution with the log n approach. Or do we have a direct formula for LCM? And to be divided by GCD of A comma B. Conditional loops. Okay. This is the one with constant time complexity. I think this is the direct solution. Sum of no wait. G equals to max and is equals to minimum of this thing. I is equal to G till I plus or equal to G. If I modulo s equals to 0, return I. What did we do here is I equals to G. G is maximum of these both. So suppose we have 3 and 6, then we take maximum of them 6 and then 18 and I modulo s. Or else if found the GCD A divided by GCD of A comma B into B. Anyways, we won't get 0 as GCD. The minimum GCD will be 1 due to the constraints we have. Also, C++ has a inbuilt Euclidean, function for this Euclidean GCD. So there is nothing to worry about that as well. 9 by 2 is 4. 5 by 2 is 2. I think there is no way other than iterating till n by 2. We'll just try it once. I'll get a TLE, that's for sure. You have to find the minimum element, not the minimum LCM. Okay. Element with minimum LCM. I'll get a time TLE for sure. or else what can I do is the thing is that LCM increases, then decreases, then increases. That's the problem. That's the thing which creates problem for us. 1,8, 2,7, 3,6. Get that yearly for sure. Hmm. Because the constraints are too large, and yeah, he prevented us from going for that approach. Either we have to do it in the constant time complexity or else the logarithmic time complexity. Hmm. 5/2. Now we have to find x for this thing to happen, for the LCM to be minimum. So we can just do the first derivative of this. This will remain a constant simply. N minus x plus minus x equals to 0, x equals to n by 2. What I got is n by 2 here. Either it will be n by 2 or n by 2 minus 1. Maybe out of these both, because what we had here is n by 2 minus 1 was the minimum, and here also we had n by 2 minus 1 as minimum. I think that's the thing. It was like, let's try it once. mm, x1 into n minus x1 divided by GCD of x1 comma n minus x1, or else LCM 2 equals to x2 into n minus x2 divided by GCD of x2 and n minus x2. Okay, now if LCM1 then LCM2, see out x1 and minus x1 and else see out x2 and minus x2 and L. Well, let's try submitting it. Oh, I got a 0. Wait, I think this won't work on the first test case itself. Hmm. Maybe what I can do is, where did it go? Oh no, I can set into as 1. LCM 1 equals to maximum of O comma this thing maximum of O comma this thing. Now let's try submitting it. Wrong answer on test 2. Name equals to 0 violates the range test case 2. Well, I knew that. Anyways, this only happens when n equals to 2. So when n is 2, I'll just see out 1 and 1. I'll simply print 1 and 1. Okay, so let's try another approach. I think the basic observation can be that if n is divisible by 2, we can just print n by 2 and n by 2, both of these numbers. And if n is not divisible by 2, what can it do is n by 2 minus 1. N by 2, floor of n by 2 minus 1. And then n minus the other number. Let's just try it. Because this was from the observation. Okay, again I got a wrong answer. Test case 2. What's the test case 2? 1, 2, 3 is 0, comma 3. What is the answer here? Answer is 1, comma 2. Let's try submitting this one. 1 and 3, 1, comma 2. If you go for 1 and 4, 2, comma 2. Well, again wrong answer. Jory's answer is better than participant's answer. Test case 6. 1, 2, 3, 4, 5, 6. This one. 3, 4, 1, 2, 3, 5, 6. Okay, what's the Jory's answer? 1, 2, 3, 4, 5, and 6. 1, comma 6. What was the query? It was 7. 1, comma 6 will give me a better LCM rather than 7 by 2. 7 by 2 is 7 by 2 is 3. 3. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 2, comma 5. Just case 6. Hmm. So I have a number n. I have to check out of all of the possible combinations. I have to check the which combination is best to give me a greater amount of LCM. 1 comma and minus 1. So the LCM of this will be always mm, what is the LCM of 1 comma and minus 1? 1 comma 3 suppose. It will be 3 or it will be always n minus 1. I have to minimize the LCM, not maximize it. So I have to stay away from this test case because anyways this won't help me anyhow. Or else we have to check for prime number, I guess. If it's a prime number, then definitely 1 comma n minus 1 will give me a good LCM, minimum amount of LCM. Because if I go for some number like let's say 23, then 1 comma 22 will give me LCM of 22, and 2 comma 21, then I'll get LCM of 42, and so on. It won't get minimized to some extent. If I go for 3, 1 comma 2. So if it is a prime number, then I'll definitely print 1 comma n minus 1. If it's not a prime number, suppose we have a number like 9, 10, it's a even number, we can definitely say that. Or else we can take help of the test cases given in the, where is the minimum? Wait, the tutorial. I have to check my submissions. The test details. So suppose the number is like 8, 9. Okay. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. He just tested it for all the number state, participants output and jury's answer. 2, 3, 4, 5, 6. For 6, 3, comma 3, 7, 8, 9, 10, 11, 12, 13, 14, 15. For 15 is not a prime number, and 15 by 2 is 7. So the thing is that the number which is creating obstacle is the odd number which is not a prime number. You have to look for it. Like this case we have 15. So for 15, 5 and 10 is the optimal answer. If I go through my approach, 15 by 2 is 7. 15 by 2 is 7 minus 1. It's 6. Hmm. What else I need to check? 15 by 3. But what if the odd number is not divisible by 3? And also it's not a prime number. For example, I have 25. Let's check for 25. 1, 2, 3, 25. Hmm. For 25, what is the answer? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 11, comma 14. How can we arrive at this? Hmm. Hmm. So for 25, what did he do is 25 by 2 is 12. The floor of 25 by 2 gives us 12. And or else what I can do is ceiling plus 1. Ceiling of 9 by 2 is 5 plus 1. Yeah, let's try the ceiling plus 1 thing. For checking the prime thing, I have the algorithm here. Sieve of Eratosthenes, so that I can check whether the number is prime or not. If prime of n, if n is a prime number, then just see out 1 and minus 1, This will be the maximum minimum possible GCD, or else if n is even number, let's say if n is even number, then simply n by 2, n by 2 handle, else in x is equal to CL of 1.0 into n divided by 2. C out, like suppose 9 by 2 we have x plus, okay, so we have to C out x plus 1 space n minus x plus 1, and then okay, we'll try submitting this one, hoping that at least this might get accepted. Wrong answer on test 1. Test case 2. Output is 1 comma 8, but 9 is not a prime number, I guess. Maybe there is a problem with my algorithm. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. I got a TLE because I ran the sieve algorithm for too much time. Okay, let's move on to checking the editorial rather than spending a lot of time on this. A equals to 1, G equals to 2, G square less than equal to N, G plus plus. If N divided by G equals to 0, A equals to N by G breaks equals to N. Oh, well, suppose A less than equal to B, then let's show that if B mod A not equal to 0, answer is suboptimal. If B mod A equals to 0, then LCM of A comma B is okay. But where do we get A and B? Answer is suboptimal. If B mod equals to 0, then LCM equals to B, so the answer is less than N. But if B mod A not equals to 0, then LCM is at least 2B and B is at least N. So in this case, answer at least N. B mod since N equal to A plus B, I determine root of N complexity. So then CM of A comma B equals to B. If B mod A equals to 0 equal to B, so the answer is less than N. But if B mod N not equal to 0, then LCM of A comma B is at least 2B. n mod a equals to 0. You have to search for a along only among the divisors of n. Divisors of n. Suppose n is 4, then along the divisors of n. 2, comma 3, comma 2, get 3. I still didn't get this thing. If a less than or equal to b, let's show that if b mod a equals not equals to 0. We have two numbers a and b. Okay. So that if b mod a not equal to 0, answer is suboptimal. If b mod a equals to 0, then LCM of a comma b is b. Yeah, that's okay. So the answer is less than n. But if b mod a not equal to 0, then LCM of a comma b is at least 2b. How it cannot be 2b. It will be at least a into b. LCM of, suppose the test cases we have 7 comma 2 or 6 comma 3, 5 comma 4, 5 comma 4 a and b. It doesn't obey the 2b thing. It will be at least a into b. Okay, okay, at least I got it. B mod a not equals to 0, answer will be at least where the condition is b is the greater one. Yeah, okay, because n is 2 here, so it will be at least 2b, and b is at least n by 2. So in this case, the answer is at least n. LCM will always be at least n. That's okay. Now we know that the optimal answer b mod equals to 0. This also means that n mod equals to 0. Mod equal to 0 since n equals to a plus b. So b is always greater than a. A plus b mod equals to 0. Okay. Let's check other submissions. How did others solve it? Minimum LCM thing. If n modulo 2 equals to 0, this thing, okay. Or else is equal to 3 to square root of n plus 1. Okay, they did in square root and time complexity. But I don't get the logic. Why did they apply the square root time complexity? B mod n not equal to 0. Answer is optimal. LCM will be b less than n. First of all, is splitted in the n into two numbers a and b, where b will be at least n by 2. Number n is splitted into a and b, where b is greater than equal to n by 2. Okay. So if b mod a equals to 0, then LCM will be b. B mod equals to 0. Suppose I have, okay, that's fine. So the answer is less than n. What will be the answer? LCM will be 3 comma 6. So the answer will be 3 and 6. Answer is always less than n. What is it referring if the answer? Where is the question? Wait once. Let me open the question. So the answer is less than n. B mod is not equal to 0. Then LCM of A comma B is at least 2B. Okay, yeah, that's okay. So in this case, the answer is at least n. What is meant by at least n?